Okay, today we are going to be looking at graphing functions, and this is going to be page 62 in our interactive notebooks. And actually today it's easier. You can glue in your examples on the right-hand side, but your foldables don't glue in until you've completed them. Okay, just because it'll be easier to write on them before they're glued in because of how they glue in and the size that they are. Okay, so we're going to be looking at graphing functions today, and we're basically just taking all of the pieces that we've already learned about, solving for y, input and output values, plotting points on the coordinate plane, and putting them all together into one problem. Our whole entire goal has sort of been working up to this. So we can graph functions that are in y equals mx plus b format, or more importantly, they are solved for y. Okay, so even if it isn't quite y equals mx plus b form, but it's solved for y, that's sort of our key. Okay, so let's say we're given y equals 3x minus 4. We know that we can make a table, and if we are given input values, we can find the corresponding output values. The difference is that today those x values aren't going to be given to us, and it's going to be our job to make them up. Now, you can literally make up anything you want. My suggestion is that since we are graphing on a 10 by 10 grid, you don't pick something like 752, right? We want to pick something that's going to be able to fit on a 10 by 10 coordinate plane, but also give us a good picture of what we're going to do. So a lot of times my students come to me and they say, well, I'm going to plug in 1, 2, and 3. And while that is not wrong, you absolutely can plug in 1, 2, and 3. 1, 2, and 3 gives us all only positive numbers. We're not quite central on the graph, and it leads to a better opportunity that will find a point that won't fit on the coordinate plane. Okay, the other number that I really like to include every single time is 0. Why? Because 0 is even easier than 1. Not only is it even easier than 1, but it also is going to tell us where our y-intercept is at. So I really like to plug in the values each time of -1, 0, and 1. We're right smack dab in the middle of that coordinate plane, and we have our y-intercept in the middle. Okay, so just like we've been doing, we're now just going to take these values and plug them each in. So now instead of saying 3 times x minus 4, I'm going to say 3 times -1 minus 4. Okay, well, this will give us a -3 minus 4, which will give us a -7. Then we'll plug in 0. 3 times 0 minus 4, which will give us a -4. And then we will plug in 1. 3 times 1 minus 4 will give us a -1. Okay, so knowing what we already know about tables and how they function inside of functions, right? We also know that this is now the ordered pair -1, 7. -7. And this is the ordered pair 0, -4. And this is the ordered pair 1, -1. So I'm going to take those ordered pairs and I'm going to plot them on my coordinate plane. So I'm plotting -1, -7, 0, -4, and 1, -1. When we only have an x, no x squared, no x to the third, right? We don't see any larger exponent on this. Our graph should be making a line. And so that's everything we're focusing on today, which means your 3 points need to be making a line. Now, that doesn't just mean, okay, just throw something down here and hope for the best. I really want you to understand this. We could pick any number of points to plug in here, right? I could plug in 0, 0.1, 0.11, 0.111. Okay, there are an infinite number of x values in here. We just can't write them down in a table. So just like we took inequalities and graphed them on a number line to represent all the spots, that's the exact same thing that we're doing down here. So when I draw this line, okay, I am making it go all the way across my coordinate plane, and I am putting arrows on this. I am much less concerned about you pulling out a ruler and making a perfectly straight line, because even then you have to have it perfectly through the center of each of these. I'd much prefer that you focus on making sure you're going across your coordinate plane and you're putting arrows on the end, because we want to understand that this represents the infinite number of ordered pairs, the infinite number of input and output values that make this function rule true. Okay, now we can also look at this where the problem isn't already in a y equals form. And if it isn't already solved for y, that means we have to do that on our own. Okay, so we've been talking about solving for y. We looked at it previously, so let's review again. Right, we want to move, if we want to get y by itself, we need to move this whole entire 4x away. So we'll move a positive 4x by subtracting 4x. So that will give us a 2y equals a negative 4x plus 10. And then we will undo our multiplication with division, knowing that goes all the way through. And we will get y equals negative 2x plus 5. Okay, and we want to look at it in this format where it's solved for y. Because just like when we were plugging in those points over here, right? It's easy to have an input value and then to plug it in and find its output value, that function rule, that function notation form. Okay, now we still have to pick our 3 input values. Again, my suggestion is still that negative 1, 0, and 1. And so we will start plugging in. So now instead of saying negative 2 times x plus 5, I'll say negative 2 times negative 1 plus 5. Oh, that ends up being a positive 2, so that's a 7. A negative 2 times 0 plus 5, which will give me a 5. A negative 2 times 1 plus 5, which gives us a 3. Okay, and so now I have 3 ordered pairs I can plot. So I'm going to plot the point negative 1, positive 7, 0, 5, and 1, 3. Okay, if for some reason your points don't look like they make a line, they look like they make a triangle, either check your math or check to make sure you plotted the points correctly. Okay, so again, we're going to make our line across our coordinate plane and arrows on both ends. Then we have this second piece of a foldable that we want to look at too. So sometimes when we graph, we get vertical lines. Vertical lines always, 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 and forever will only have one variable in it, and the one variable that we see is x. Okay, so only seeing x equals tells us that it's vertical. However, if we go to make this table, it tells us something else. I can't randomly pick whatever I want x to equal, because it tells me x has to equal 5. No matter what value I pick, it has to be 5. Now, y can be anything it wants. This doesn't say anything about y. It only tells me what x has to be. So y could be negative 1 or 0 or 1, but x has to be negative 5. Okay, so I can then plot these points. So I'm going to plot 5, negative 1, 5, 0, and 5, 1. And we will notice, right, that this gives us a vertical line. And this vertical line is at 5 on the x-axis, right? I'm going on the x-axis to 5, and it's giving me a vertical line. Now, we'll see the flip of that happen if we have a horizontal line. So we will notice here we only see one variable, but it says y equals. So I can still pick my x values to be negative 1, 0, and 1. But no matter what my x value equals, I don't even have a place to plug it in. It just tells me no matter what, y is negative 3 each and every time. So if I go to plot these points, I'll get -1, -3, 0, -3, and 1, -3. And so here I get a horizontal line. Okay, now what you'll want to do is you will want to take these foldables and glue them both in over here. Okay, so you add these both to your notebook so they are glued in over here. And then we have a few examples to look at. Y equals 5x plus 4. So we know we can pick our input values. So let's say we pick -1, 0, and 1. So 5 times -1 plus 4. This is a -1. 5 times 0 plus 4 gives us 4. 5 times 1 plus 4 gives us a 9. So if we plot our ordered pairs, we'll have -1, -1, 0, 4, and 1, 9. Going across the coordinate plane and putting arrows on both ends. Okay, for our next one, it's not solved for y, so we are going to want to solve this for y. So 6x minus 3y equals 12. I know I need to move this x first. So that will leave me with a -3y. These are not like terms, so a -6x plus 12. I will then undo multiplication with division. And I will get y equals -6 divided by -3 is 2x minus 4. Okay, so I now want to use that y equals 2x minus 4 and plug my values in with that. So -1, 0, and 1. So I'm going to squeeze this in. 2 times -1 minus 4. It's -6. 2 times 0 minus 4 gives me a -4. And 2 times 1 minus 4 gives us a -2. So if we go to graph this, we'll plot -1, -6, 0, -4, and 1, -2. Okay, and then finally on our last one, it is also not solved for y. Y is not by itself, but notice that x isn't over there with it. Okay, so when we talk about looking at this and solving it for y, that x is already moved. So the only thing that we need to do is divide by that 4. So that will give us a y equals 3x minus 1. So if we pick our input values, 3 times -1 minus 1, so -3 minus 1 is -4. 3 times 0 minus 1. 3 times 1 minus 1. Okay, so -1, -4. 0, -1. And 1, 2.